Hello everyone, my name is Subham Mahto and today we will start a very good topic that is based on inequalities. So this will be a complete lecture series on the topic inequalities. So this topic is useful for those people who are preparing for IIT JEE and Advanced, those people who are preparing for Olympiad exams and many mathematical competitive exams. So before going to this topic, I want to give a very good motivation, and this motivation is actually a story that will help you to understand this topic, right? My story is what? So there is a school, right, in some place. In that school, an exam is going on, right? Exam is going on. In that exam, total marks, total marks is 100. So there are many students who are giving this exam. Suppose one student is there whose name is Amar, and Amar given this exam and he got a marks of X, means his marks is X, right? Now Amar parent, that parent want to know that his son passed this exam or not. So he went to the examiner, right? Examiner is there, or we say that his teacher. So there the teacher given some condition about the pass and fail. He said that if marks is above 35, then your son pass. That means if the marks of the Amar, that is X, is greater than 35, then pass. Or instead of writing this, I can write like this: X is greater than equal to 36, then also pass, right? Then also pass. So if marks is greater than 35, then the child passed, that Amar is passed the exam. But what happen if the marks is less than equal to 35? Then surely he fails. Or we can write this as X is less than 36. Then also we can say that Amar failed the exam or failed the exam. So this is the scenario when Amar parent went to the examiner. He said that your son marks is greater than 35 or greater than or equal to 36, then your son pass. Then he realized that if his son marks is less than equal to 35 or less than 36, then his son failed the exam. So from this story, we will observe or we see that there are four types of inequalities. So the first one is greater than, second one is greater than equal to, third one is less than, and the fourth inequality is less than equal to. So these are some inequalities, that is the only inequalities about which we will learn today, and in this complete lecture series we will solve many examples, we will solve many good problems, Olympiad problems, IIT JEE problems that is based on these concepts. So before going to the problems and something, we will learn some basic concept about this inequality. And after that we will solve many examples, some simple examples, then we will increase our level of problem, and then we will solve up to advanced level, IIT JEE levels, Olympiad levels. Okay, so let's start with the basic rules. So my first basic rule is transitivity. It says that if you have three number, say A, B and C, and if A is less than B and B is less than C, then this property says that A is less than C also. Example, 2 is less than 3 and 3 is less than 4. So obviously we, we know that 2 is less than 4 also, right? So that this property states. And this is not only for this less than inequality only. This is true for less than equal to also. So if A is less than equal to B and B is less than equal to C, then A is less than equal to C also. Example, 2 is less than equal to 4, right? This statement is correct. And 4 is less than equal to C, 6. Then obviously 2 is less than equal to 6 also, right? So this is the transitivity. So other two you can write by yourself. That is, if A is greater than B and B is greater than C, then this transitivity property says that A is greater than C. And one more is, if A is greater than equal to B and B is greater than equal to C, then A is greater than equal to C. Understood? I hope you understood this property, that is transitivity property, and we can feel this property by taking some particular example. So now the next property is addition and subtraction. So what this property says? This property says if A is less than B and C is a number, that is C belongs to R, right? Any real number, or we say that C is any constant. C is any constant. Then if we add this constant C to both sides of the inequality, then also the inequality will not change. The inequality will maintain, right? So for example, suppose, so 2 is less than 3 we know, and suppose my C is 2, then 2 plus 2 is what? 4, and 3 plus 2 is what? 5. So obviously this 4 is less than 5. So what is happening here? We added 2 on both sides of the inequality. The inequality not changed, right? So there is no effect on the inequality, right? So this you can write for less than equal to, greater than equal to. Now the second point is, if A is less than B and C is constant. C is any constant. Then if I subtract this C by both the side of the inequality, then also this inequality will not affected or not changed, right? For example, 2 is less than 3 and I am taking my constant C equal to 2, then 2 minus 2 is 0 and 3 minus 2 is 1, and obviously this 0 is less than 1. That is satisfied, right? So this property is true for less than, right? Similarly, this property is true for less than equal to also, greater than equal to also, and greater than also. So it is a homework for you to write this property for the other inequalities, right? I hope you understand this property of addition and subtraction. Now the third property is multiplication and division. So the third property is and division. So in multiplication and division, I will first write for the multiplication. So if we have two number, suppose A and that is less than the other number B, and C is my the third number, right? And that C is positive for me. Then what will be the inequality sign if I multiply this C on both sides? So if we multiply, then I will get BAC and BC. Now because of C is positive, so the inequality sign or inequality will not change, that will remain same, right? But if this C is negative, right, then in this case the inequality sign or inequality will change. It become greater than in place of less than. So we will take one example to understand this property properly. So suppose 2 is less than 3. Then if I multiply both side 4, then what will happen? The inequality sign will or inequality will not change. Why? Because 4 is so 2 is less than 3, right? And I am taking my constant C is equal to 4. So 2 into 4 is 8 and 3 into 4 is 12. So clearly this 8 is less than 12, right? So after multiplication, the inequality not changed. This is because why? 4 is positive. But if C I taken minus 4, then 2 into minus 4 is minus 8 and 3 into minus 4 is minus 12. Now here if you see, then minus 8 is greater than minus 12. So after multiplying with negative number, the inequality changed. From less than it become greater than. This is because of negative quotient, because the C is less than 0. So hope you understand this multiplication property by this example. So what happened in this property? If we have an inequality and if we multiply the inequality with a positive number on both sides, then the inequality will not change. And if we multiply with a negative number on both sides, then the inequality will change the sign from greater than to less than and less than to greater than. So here it is less than, so it change to greater than. If instead of less than it is greater than, then it will change to less than. So I hope you will write for the other inequalities, that is less than equal to, greater than and greater than equal to. The same rules true for other inequality also on multiplication. Now if we go for the division, then what will happen? So if A is less than B and C is any constant that is greater than 0, then what will happen? A by C will be less than B by C. Now see, this C is constant, so and positive, so 1 by C also a constant and that is positive. So if you use the previous rule, that is multiplication rule, then that will give you the condition that it will not change the inequality. So similarly it is true for C less than 0. Then what will happen? A by C will be greater than B by C. Because of negative constant, the inequality will change, right? Now see, in both case we never taken C equal to 0. So what happen if our C is 0? So if C equal to 0, right, then suppose we have A less than B. So if you multiply C on both sides of the inequality, what will come? a into 0 and b into 0. Now see, these both are equal to 0. So if you see here, the inequality is removed, vanished. So that's why we never use c equal to 0, right?
So next we move for the fourth rule, and also now we shall move for the fifth rule, that is applying function on both side of inequality. So the first point I want to write is, suppose a1 is less than equal to b1 and if f is a function is monotonically increasing, then if we apply the function, then it will not change the inequality, that is f of a1 is less than equal to f of b1. But if f is monotonically decreasing, then f of a1 will be greater than equal to f of b1. So in the case of monotonically decreasing, the inequality will change, right? Now see, instead of a1 less than equal to b1, if we have a1 less than b1, then also after applying the function it will be less than equal to in the case of monotonically increasing and greater than equal to in the case of monotonically decreasing. So hope you understood this point. But if suppose a1 is strictly less than b1 and if f is strictly monotonically increasing, then in this case the strictness will maintain, that is f of a1 is less than f of b1. So if it is monotonically increasing only, then we will get f of a1 less than equal to f of b1 for strict inequality. But if it is strictly monotonically increasing, then the strict inequality will be maintained, right? It will not the less than equal to, it is less than only. Now if f is strictly monotonically decreasing, then the strict inequality will change to another strict inequality, that is if previous is less than, then it will be greater than, right? So hope you understood. Now this will be same theory will be for greater than equal to and greater than. So hope you understood these concepts.
So now we will move for some examples. So these examples are used as a result also, and this is a particular example of the last point, that is applying function on the inequalities. So the first problem I want to ask is, suppose we have an inequality A less than equal to B, where both of these are positive number. Then what can you say about 1 upon A and 1 upon B? So see, actually what we are doing reciprocal. And reciprocal is a decreasing function in the positive domain. In the positive part. Means if the numbers are positive, then it is decreasing function and it is strictly decreasing function. So because here it is less than equal to, so because of decreasing it become greater than equal to after reciprocal. Hope you understood. And see, these two numbers A and B are positive. That's why this reciprocal will be also positive. So hope you understood this. So I am taking a particular example of this case. Suppose 2 is greater than 3 and this is less than equal to 3. Then clearly 1 by 2 we can write as greater than equal to 1 by 3, right? And these both are positive. See here, greater than equal to sign I am writing because in the initial inequality we have less than equal to. Now suppose my A is less than equal to B, but these both number are negative now. Then what will happen? Then what will be the inequality in 1 by A and 1 by B? See, this reciprocal function is strictly decreasing in the negative domain also. That's why this inequality will change to greater than equal to here also. But because this A and B are negative, so that's why its reciprocal is also negative. Means 1 by B also negative and 1 by A also negative. So hope you understood this one, right? Now I am taking one particular example. Suppose minus 3 I am taking, that is less than minus 2, and these both are negative. Then clearly 1 by 3 is greater than equal to minus 1 by 2, and these both are negative, right? So this you can feel by taking particular example also. Now the third one I want to ask is, what happen if one will be positive and one will be negative. Suppose A is less than 0 and B is greater than 0. Then what will happen? About then what will happen when we do the reciprocal? So 1 by A will come and 1 by B will come. Now see, because A is negative, so 1 by A is also negative, right? And because B is positive, so 1 by B also positive. So here the inequality will not change. Here we have this type of scenario. For example, if I take a particular example, then minus 2 less than 0 and 2 is greater than 0. So clearly 1 minus 1 by 2 is less than 0 and 1 by 2 is greater than 0, right? So this is the scenario of reciprocal. When we do reciprocal in the inequality, so these are the cases, and in these cases these are the results, right? So now we will move for the next operations, that is exponenting. What does it mean? Suppose we have two number, say A and B, and they are satisfying this type of inequality. Means both number are positive and A is less than B. Then what we can say, if we raise the power of A with positive 1, like A to the power R I am doing, where R is my positive number, then how this A to the power R will be related to B to the power R. So see, this exponenting power is strictly increasing, so it will not change the inequality. And because A is positive, B is positive, so taking power is always positive, so this will be greater than 0. So here the point is to think that my numbers are positive and my power is also positive, right? Now what will happen if I take negative power? So if R is negative, so if we do negative power, then this function will be strictly decreasing, and because of that this a to the power will be greater than b to the power. That is, the inequality will change, and by taking power it will not change the positivity, so it will be always greater than 0. So here the condition you have to remember that this power should be positive. In that case, inequality will not change, and when power is negative, then inequality will change. So this is the scenario when my two numbers are positive. So hope you understood this. So I will take one particular example for more understanding. So suppose we have two numbers 0 less than 2 less than 3. Then clearly 2 to the power 2 is less than 3 to the power 2, and these are positive. But 2 to the power minus 2, that is 1 by 4, is greater than 3 to the power minus 2, that is 1 by 9, and these both are positive. Okay, so this is the particular example. Now we will move for another case. Now the fifth case is same as exponenting. So if a is greater than 0 and this is less than 1, then what will happen if I raise a to the power r, where r is positive? This will be less than 1 or greater than 1. So if a is less than 1, then this will be greater than 0 and less than 1 only. But if my r is negative, so in this case what will happen? In this case, my a to the power minus r will be greater than 1 and greater than 0 also. So in this case what will happen? This a to the power r will be greater than 1. So this can be understood by an example. So for better understanding, I will use one example. Suppose 1 by 2 I am taking as a, so this is less than 1. Now if you do the power 1 by 2 to the power 2, then this will be 1 by 4, and that is less than 1 and greater than 0. But if you take 1 by 2 to the power minus 2, then this will be 2 to the power 2, that is 4, and this is greater than 1. So here the power is 2, that is greater than 0, and here the power is minus 2, that is less than 0. So this is the condition. Means in positive power, if my number is between 0 to 1, then in positive power it will be between 0 to 1 only, but in negative power it will be greater than 1. Now a similar type of case I want to ask, when my number is, that is b, and this is greater than 1, then what will happen if I raise it some power? So if I do b to the power r, where r is positive, then this will be greater than 1 only. But if I take b to the power r, where r is negative, then this will be less than 1 and greater than 0, right? So I am taking one example, like suppose we have 2 that is greater than 1, then this 2 to the power 2 is greater than 1 because 2 is positive, and 2 to the power minus 2, if you see, then this is less than 1 and greater than 0 because minus 2 is negative. So hope you understand these two cases, right? 1 and 2. Here the power domain is very important. Means we are taking positive one or negative one. This one condition is important. And one more thing is important, that where my points lying A and B. It is between 0 to 1, or like how they are related, right? So these are some examples. So the next case will be logarithm when we apply log function on the inequality. So see, this log is like have a base and some input A. So this log function is strictly increasing, or we can say monotonically increasing, when this base is greater than 1. But this is strictly decreasing in its domain when b is between 0 to 1. So suppose we have an inequality, it is x is less than y and this x is greater than 0. Then if I apply log with base b x y, then between these two numbers the inequality sign will be less than only, means the inequality sign will not change if my b, that is base, is greater than 1. But the inequality sign will change to greater than if my base is between 0 to 1. Why? Because with base greater than 1, my log function is strictly increasing, so inequality sign will not change. And between 0 to 1, my log function is decreasing, so the inequality sign will change. So hope you understood this one. Okay. Now we will take a particular example. Say, so I'm taking one particular example where my inequality is like this. Then if I apply log on both sides with base 10, then this will be 10 equal to 1, and that is less than log with base 10 on 100, that is equal to 2. So clearly 1 is less than 2. Why? Because here 10 is the base and that is greater than 1. But if I use log with base 1 by 10, right, on this function, then this will be how much? This will be minus 1, right? And that is greater than log 1 by 10 base 100, that is equal to minus 2, right? So here the inequality sign will change because 1 by 10 is between 0 to 1. So this is the concept. So hope you understood this concept. So these are the some basic rules and some standard examples that you have to remember and you have to keep in your mind while solving the problems. So hope you like this video and it will be helpful for you. So if you like, then please subscribe also, and we will meet in the next video. For now, thank you and bye.